Okay, good morning, good afternoon, good evening. We are back again with our revisions as we prepare for the supplementary exams. Okay, that is in BS-140, Business Mathematics, Mathematical Analysis. So I have a question with me there. Hopefully it is visible. Yeah. So we'll go through that question and plus other questions which we might have this morning. Yeah. Okay, so the question says, I'm sure this is a question you should have the knowledge on demand and supply. On this question you should have the knowledge on demand and supply. So the question reads as follows: the demand functions for mathematics lessons at a certain institution in Lusaka is given by the following. So remember, when we look at the market, we are simply saying the market is being affected in terms of two things: the demand and the supply of quantities. So in this case, the demand most of the time is given on the particular maybe aspect of the number of customers coming in of a certain quantity, and the supply talking about what is available based on what is being produced. So in this case, most of the time the demand function is basically given as an equation in terms of the price which the buyers are willing to pay. So we have the demand, which is given by P, as usual, which is our price, to be equals to 2000 minus 5Q. And then we have the supply, which is given by P to be equal to 920 plus 4Q. So sometimes equation they can just basically simply say that no, the demand and the supply function are given as follows. They don't even state which one is the demand and which one is the supply. So how do I know that this is a demand function? The demand function will always have a negative gradient. The supply function will always have a positive gradient. So what are we having here? A negative gradient emphasizes that price and the quantity are basically negatively related. Price and quantity are basically negatively related when it comes to the demand function. So this is basically a type of function which shows the relationship which exists between price and quantity, that they are negatively related. As price increases, then the quantity of demand will decrease since price has increased. That is why you find that maybe the price of a phone is basically 2000 kwacha. You have, let's say, 10 customers at that particular time. You increase the price of the phone to 2500. So if I have a 2000 kwacha, this is the price of my phone. Then we increase this price to 2500. What is going to happen to our quantity of demand? If the quantity of demand at 2000 was equal to 10, then we increase at 2500, we're expecting maybe this to basically to lower down. So not obviously everyone can afford a 2500. You'll discover that the people who come for 2500 do decrease. Maybe we'll have, maybe at this particular time we can have 6 people coming for this particular phone when it is at 2500. So that is why we're simply saying the demand function is negatively related. As price increases, quantity decreases. As quantity decreases, price increases. In those manner, they are negatively related. Unlike for the supply it is positively related. When quantity of supply, then the price increases, even the quantity of supply tend to increase. Yeah, so this is what the question is talking about, of the demand and the supply there on the market. And then we're being told to find the equilibrium price and quantity. So we are trying to find the equilibrium price and quantity. So what do we mean equilibrium price and quantity? So at the market equilibrium, remember the market is basically influenced by the demand and the supply. So every time we look at market, so the concept here is that at market equilibrium, the quantity of demand should always be equal to the quantity of supply, or we can simply say the price of demand should always be equal to the quantity of, the price of supply. So this is more like an equilibrium condition which we always use when we are at the market equilibrium. So that is our equilibrium condition which we are going to be using every time when we are at the market equilibrium. So in this case, what do I have? My functions in terms of P. So I'm going to use this condition. So PD should be equal to PS, implying that 2000 minus 5Q should be equals to 920 plus 4Q. Then when you do the simplification, like terms together, I'm going to have 2000 minus 920 to be equals to 4Q. When this one goes to this side, becomes 5Q. So that we can have 9Q this side, and this side we can have what? A 2000 minus, do I have a calculator? A 2000. So if you do the typing on the calculator, we have 2000 minus 920, which is going to give you something equivalent to 1080. We are finding Q over 9 over 9. So if we divide this by 9, I'm going to have something like Q to be equals to 120. So this Q which I found is basically my equilibrium quantity QE. So the question says find the equilibrium quantity and price. So the first part which we have found here after equating PD to PS is basically equal to the equilibrium quantity, equilibrium quantity. So now let's find the equilibrium price. The equilibrium price, since it's at equilibrium point, we can use any of the equation to find the price. We'll have the same value for P. So if let's say I use the first part, P is basically equals to 2000 minus 5Q. Q is 120. Then this equals to 2000 minus 5 multiplied by a 120. What am I going to have? 600 subtract from a 2000. Our P should be equal to 1400. This is our equilibrium price. So when the first question we say is find the equilibrium price and quantity, our equilibrium price PE is basically equals to 1400, and the equilibrium quantity is basically equals to a 120. That's the part. So it means that when we're at market equilibrium, I want you to have an understanding of this. Let's say this is my sketch. This is my quantity axis, and this is my price axis. When this demand function is sketched, it is a negative gradient, it is going to slope in that direction. But this is a supply function, it is a positive gradient, it is going to slope in that direction. The price intercept for the supply function is at 920. The price intercept for the demand function, which is at 2000, somewhere there. So if this is my non-can, then at this particular point where they tend to meet is where we are going to be the equilibrium point, or the equilibrium market EO. So at this particular point, we are simply saying the equilibrium quantity here should be 120, and the equilibrium price here should be equivalent to a what? A 1400. That's what we mean. So that's basically the representation of the market equilibrium. But they didn't tell us to sketch, but basically that's why how briefly a graph should be able to look like. Now let's go to the second part. Let's go to the second part, which says now, in a situation, okay, so let me just delete this part. And I can just keep my values. Let me try to keep my value for PE. PE is equals to 1400 and QE is equals to 120. I've kept my prices so that I can go to the next question. It says, if the government imposes tax imposes tax of 90 kwacha per lesson. So we have a situation there where the government imposes a 90 kwacha per lesson. Write down the equation of the supply function adjusted to tax. So now, there are two scenarios here. They can either be a subsidy or they can either be a tax which is being imposed on the type of quantities we are dealing with at that particular time. So in this case, we have tax. So basically, if there is tax, what do we expect? Obviously, we're expecting someone to pay more, if you are not mistaken. If there's subsidy, but somehow we're trying to expect to pay less, it has been subsidized. So in this case, a 90 kwacha is tax which has been imposed. So every time when you're trying to come up with new equations, always take note that when there's tax, or when there's tax or subsidy which has been imposed, this only affects the supply equation. So this only affects the supply equation. The demand function remains the same. The demand function remains the same. So the demand function will always have an effect of it when it comes to making payments, but the demand function remains the same. So when making payment, that's where the effect comes in most of the times. But usually it is basically the same function which we are going to deal with. So if we have the odd supply equation to be equals to P to be equals to 920 plus 4Q, remember this is the price. So this is the price. P is equals to this. Obviously, if there is tax imposed, we are looking at the price, the new supply function, this time around to change to be equals to 920. So let me say after tax. Then our PS, which is a supply function, should be equals to 920 plus 4Q plus tax. This is what we're expecting to have. If it was subsidy, what am I expecting? I'm expecting to have PS to be equals to 920 plus 4Q minus subsidy. Take note of these two equations. So every time when there is tax or subsidy imposed, what is affected is the supply function, but the demand function remains the same. So 920 plus 4Q, if it is sub-tax, we are adding tax to the price equation. If it is subsidy, we are subtracting subsidy to the supply function. This equation works every time when P is the subject, but sometimes you'll find that the function is not as P the subject. Maybe they've given you the functions as Q the subject. So you have to be strategic in that manner. So this only works for when P is the subject. So when P is the subject, you just add tax to the equation or subtract subsidy to the equation. In this case, we're dealing with the tax. So you can delete this part. So our new equation now is going to be equals to P to be equals to 920 plus 4Q plus tax is what? 90 kwacha, which is a 90. Like terms together, P will be equals to 920 plus 90 plus 4Q. So that we can have my 920 plus a 90, which is going to give me a P to be equals to 1010 plus 4Q. This is my new supply equation. After tax was being imposed. So once you calculate the new equation, the next part now is basically for you to calculate what is known as the new equilibrium price and quantity. The same thing as we did in the first place, where we are simply saying for this one, we want to find the new equilibrium point. It means at equilibrium, PD should be equals to PS. PD did not change, it is still the same PD, but PS has changed to this guy. So it means that I'm going to have PD to be equals to 2000 minus 5Q to be equals to PS now, which is this one, the new supply function, which is 100 plus 4Q. So that when we do 2000 minus 1010 to be equals to 4Q plus 5Q. So this is now going to be equals to a 9Q. This and that will now be equals to 2000 minus that. So 2000 minus 1010. This is 990 over 9 over 9, so that the equilibrium quantity becomes 110. This is the new equilibrium quantity, and the new equilibrium price will now be equal to 2000 minus 5 open bracket 110. So we use either this equation or that equation to solve for P. Remember, we are dealing with a new supply equation if you are using the supply equation. So if I use that, I'm going to have 5,005 multiplied by 110. Then the answer we subtract from the 2000. Automatically my new equilibrium price is now going to be equal to 1,450. This is my new equilibrium price. So what is happening here after tax? After tax, we have PE to be equals to 1,450, and we have QE to be equals to 110. That's the information we have. So that with that information now, what is going to happen? We can now go ahead and calculate the distribution of the tax. That is how much tax is paid by the student and how much tax is paid by the institution. So every time this tax is being imposed, despite the equation which is being affected, we simply say that this 90 quarter is being distributed between the customers and the suppliers. So it's supposed to be distributed based on a certain ratio. So how am I going to distribute this 90 quarter? So can I delete this part? I'm sure you're following, can be pausing, but let me delete this part. Okay, somewhere here. So we're talking about distribution of tax. So under the distribution of tax here, remember the buyer's part, the customer's part, the demand function is what explains the customer's part. The supplier's part, the producers, is what is being explained by the supply function. So if you want to look at the distribution of tax, remember tax imposed here was a 90 quart. The demand function here is what gives the explains terms of the suppliers. So the demand function was 2000 minus 5Q. The supply was 920 plus 4Q. That's what we have there. So now, what are we looking for? How are we going to distribute this 90 quarts? So the first method is you look at the gradient. So tax paid by consumers. Consumers are basically customers. So in this case, our consumers are basically the students, since they're the ones buying the service. So tax paid by the consumers will go in the demand function. So we're looking at the gradient for the demand function, which is absolute value of MD over absolute value of MD plus MS multiplied by the tax is what tax is paid by the consumers. So what do I mean by MS? MD means the gradient for the demand function because I'm dealing with the consumers. But if you want for tax paid by what? The suppliers. What do I do? It is MS, which is the gradient for the supply function, over gradient for MS plus MD multiplied by tax. Look at this, I'm putting absolute value, it means I'm just concerned with the positivity. So the gradient here is -5, but because of the absolute value, it's going to come out to be +5 over 5 plus the gradient for the supply, which is a 4. The answer multiplied by the tax, which is a 90. So this is now going to be equal to 5 over 9 multiplied by 90, which is equal to 9 there is 1, 9 there is 10. This time that is equal to 50 kwacha. So 50 kwacha is paid by the consumers. And in this case, our consumers are the students. If I go to the suppliers part, we're talking about the gradient for the supply, which is a 4. So I'm going to have 4 over 4 plus 5 multiplied by the 90 kwacha. So this is equals to 4 over 9 multiplied by 90. This is equals to 9 there is 1, 9 there is 10. 10 times 4 is 40 kwacha. Is paid by the suppliers. And the suppliers in this case is the institution. And you are done. So this is basically how you are going to solve the distribution of tax, or even if it was distribution of subsidy. So distribution of subsidy, the same thing, the same formula, but here it will be subsidy. As simple as that. What is going to be paid by the consumers and what is going to be paid by the suppliers. So 50 kwacha, this 90 kwacha, 50 kwacha is going to be paid by the consumers and 40 kwacha is going to be paid by the suppliers. Remember the total 40 plus 50 is basically equal to a what? A 90 kwacha. If this method is basically difficult, what is paid by the consumer is basically the new equilibrium price subtract the old equilibrium price. 1,450 minus 1,400, you have a 50 kwacha. This is the same 50 kwacha as here. So the new equilibrium price, so which is P2 minus P1, which is 1,450 minus 1,400, is basically equals to 50 kwacha. This is what is being paid by the consumers. And then if you want to see what is paid by the suppliers, the total tax 90 minus the 50 kwacha is basically the 40 kwacha. As simple as that. So that is how basically you deal with the demand function question there. Okay, so now let's go to the second part of the question. I'm looking at now this certain different question now where we are going to binomial concept. So this question says that find the independent term. Find the independent term of x in the expansion of x squared minus 1 over 2x raised to the power 3. We are looking for the independent term. Now, when this is expanded, obviously, according to this information, there must be a term which does not have x. That's what we mean. By us looking for the independent term of x, we are looking for the term which is going to not have x. So that term is going to be defined like how? First step. The first step is you analyzing that. Assume the independent term is found at R plus 1 position. So if the term is found at R plus 1 position, so what are we talking about? Then T R plus 1, it means the term at R plus 1 position is basically equals to N combination R plus 1 minus 1. Remember this formula? N combination R plus 1, which is this. So what term you are looking for, when it enters the combination, it decreases by 1. Closed. N, which is this, minus C, which is this, minus R plus 1 minus 1. And then B, which is our second term in the expansion, power this guy, which is R plus 1 minus 1. So that when you simplify this, then TR plus 1 is basically equals to N combination, 1 minus 1 is there, N combination R, A power N minus R, B power R. So this is the first task which is required for you to do. So assume that the independent term, it is found at basically at that position. So it means if it is found at R plus 1 position, then this is my formula. A is representing the first term, so A is x squared. B is representing the second term, negative 1 over 2x, and N is representing the power, which is the 3. So if I write down A should be equals to x squared, B should be equals to negative 1 over 2x, and N should be equals to a 3. So what do I do in this formula? We have to replace everything and solve for R. We have to replace everything and solve for R. We are looking for the independent term, but we do not know what R is. We know everything and we don't know what this R is. So our task is to replace everything and solve for R where the independent term is going to exist. The independent term should not have x. In this case, it's the independent term of x. So it means our focus is to make sure that x should not be on that term. That's the focus. So if I replace everything, we're talking about TR plus 1 should be equals to N is 3 combination R. A is x squared power N minus R, 3 minus R. B is negative 1 over 2x power R, which I don't know. Okay? So, if that is the case, then we are going to now simplify that equation with an understanding that we are looking for the independent term of x. So first thing is first, let's simplify the power there. So we're talking about TR plus 1 to be equals to 3 combination R. This times everything there. It means I'm going to have x power 6 minus 2R. Multiplied by this R is for the numerator and the denominator. It means I'm going to have negative power R over 2x power R. Now, this is my simplified equation. Now the question is, for me, for this term to be qualified to be an independent term of x, what is going to happen is that the x should disappear, and the x can only disappear if the powers in the numerator and in the denominator of x, they are the same. For example, look at it in a scenario whereby if I have x power 5 over x power 5, this and this can cancel out. If let's say I have x power 6 over x power 6, this and this will cancel out. But if, let's say, I have x power 4 here and x power 5 here, it won't completely cancel out. The 4 and the 4 will cancel out, will remain with 1 over x. It means the x will still exist in this function, but we don't want the x, that is why we're saying independent of x. So we want this x to completely be deleted. How can this x be completely be deleted if these powers of x are the same, so that we will cancel them out? Okay, this is division. So what is going to happen? We are going to solve for r. It means the only way this function can be independent of x is when 6 minus 2r, which is the power of x in the numerator, should be equals to this r, which is the power of x in the denominator. So if this is the case, therefore simply saying x is equals to r plus 2r when this one goes to the other side, implying that 3r is basically equals to what? 6. And if 3r is equals to 6, then this implies that r is basically equals to what? A 2. Because divided by 3 divided by 3, our r is going to equal to a 2. So now, since the value of r has been found, we can now go ahead and replace r with 2 to solve for this independent term. So everywhere now where there is r, we can put in 2 in this equation, so that we can now solve for this particular term. Well, okay, so allow me to just delete this part. So if I replace these 2 in this, we are going to have tr plus 1 to be equal to 3 combination r, which is the 2. Actually, it's supposed to be 2 plus 1. And then we have x power 6 minus 2, open brackets 2, multiplied by negative 1 squared over 2x power 2. So that this is basically a T3. It means my independent term is on the third term, to be equals to 3 combination 2 x, this is a 4, 6 minus a 4, it is squared, multiplied by negative 1 squared is 1, over, this is squared 4x squared. Now at this particular stage, it is x squared and x squared can go automatically. That's what we wanted. And then from there, now, what is going to happen? We can go ahead and find what is in the 3 combination 2. 3 combination 2, even if you don't even use your formula, since you guys are using calculators, 3 combination 2 is basically 3 combination 2 will give you, I think, a 3. So T3 will now be equals to 3 multiplied by, there is a 1 here, over, there is a 4 there, which is going to give me a 3 over 4 as my independent term of x. So what is this term? This term does not have any x. So if you have this term, you are finding for independent term of x, and then you find that T3 is equals to, let's say, 3 over 4x, just know that you are wrong. You are looking for the independent term of x. It shouldn't have what? X. So this is my final answer in terms of the independent term of x. Very simple, very nice. Okay, then let me look at another one on the same topic, but this time around I'm simply saying find the independent term. Find the independent term of So instead of finding the independent term of x, we are simply saying find the independent term of y. So find the independent term of y in the expansion, y minus x over x squared, over y squared, closed power 9. That is the function we have. Find the independent term of y. This time around it is the independent term of y, not x. Previous part it was the independent term of x. So our focus was on x, but here our focus should be on y. So as usual, what did we say? Assume, isn't it? Assume the independent term of y is found at tr plus 1 will be equals to at r plus 1 position. Automatically we know that tr plus 1 this time around is going to be equals to 9 combination r. We've already simplified this function, this equation in the previous, where we said tr plus 1 should be equals to a n minus r b power r. Because it is minus 1 shan, I think we've already simplified this one in the previous one. So what is our next stage? It is to solve for r. Here a is equals to y, b is equals to negative x over y squared, and n is equals to 9. Replace everything there. We're going to have tr plus 1 will be equals to 9 combination r. A is y, 9 minus r, b is negative x over y squared power r. We want to solve for r, means that tr plus 1 is equals to 9 combination r, y n minus r. This r is for the numerator and the denominator, means negative x power r over y to r. Independent term of y is our focus. So the powers should be equal to each other of y, for y to cancel out with the y in the denominator. If I was finding the independent term of x, I could have just equated this r to 0, because the only way this x can disappear if when r is equal to 0, because this power 0 will be a 1, then x will disappear. But since I'm looking for the independent term of y, it means the powers of y in the numerator and the denominator should be the same for it to cancel out. So it means that this implies that 9 minus r should be equals to 2r. So that when that crosses the other side, becomes 9 is equals to 2r plus r, which is 9 should be equals to 3r over 3 over 3, and r should be equals to 3. So implying that our independence term is equals to t 3 plus 1, r is 3, to be equals to 9 combination 3, y 9 minus a 3, negative x power 3 over y power 2 times a 3. So that this is t4 to be equals to 9 combination 3, y power 6, this is negative x power 3 over y power 6. Y power 6 and y power 6 will go, and basically 9 combination 3 should give you 84. Then this have gone multiplied by negative x power 3. This will be equals to negative 84 x power 3 as our independent term of y. As you can see, does this function have any y? It doesn't have any y. It qualifies to be called an independent term of y. Thank you very much. See you in the next lesson.